Questions on logarithms.
Okay, without using calculator or tables, find the value of log 3.6, given that log 2 is equals to 0.3010. Log 3 equals to 0.4771 and log 5 equals to 0.6990. First of all, you know that log 3.6 is equal to log 36 all over 10 to fraction, from decimal to fraction. Breaking to its lowest term, you have 2 in 10, 5, 2 in 36, 18, gives you log 18 over 5, which is the same as log 2 times 9 all over 5. You know we are talking with respect to 2, 3, and 5. We have 2 here, we have a 5 here. How can we make 3 of this? This can be written as 3 squared. Of course, using the product rule, you can.
Product rule, multiplication becomes addition.
Quotient rule, division becomes minus.
Power rule, exponent drops behind.
And say log 2 times 3 squared is equals to log 2 plus log 3 squared minus log 5. Equate the following. 2 is equals to this. So where you say log 2, you put this. Where you say log 3, you put this. But this is 3 squared, so it becomes 2 log 3.
Product rule, multiplication becomes addition.
Quotient rule, division becomes minus.
Power rule, exponent drops behind.
I'm written as 2 log 3. That's 2 times log 3 here is 0.4771 minus log 5. So when you add this and then minus this, you're going to get 0.5562. This is my final answer without using calculator or tables.
Product rule, multiplication becomes addition.
Quotient rule, division becomes minus.
Power rule, exponent drops behind.
Given that the square root of x is equals to 1.6741, without using calculator, find the value of x. In this case, you would want to find the log of both sides, log of square root of x and log of this. So since we know that this is the same thing as raised to power 1 over 2, write it as log x raised to power half equals to log 10 raised to power 1.674. Now applying the power rule, you know that this comes here. This one also comes here, the power rule of logarithms.
Product rule, multiplication becomes addition.
Quotient rule, division becomes minus.
Power rule, exponent drops behind.
So you remember that if you do not see anything here, it's automatically base 10 here and base 10 here. And identity of common logarithms tells you that this will give you 1. Logarithm of 10 to base of 10 is equals to 1. You know, you know that 10 raised to power 1 equals to 10, right? So that means this is equals to 1. So it's just like 1 times 1.6741. It remains 1.6741. So we can eliminate this. Also bear in mind that half log x is the same thing as log x all over 2. Now you know that this comes here. So 2 times this. Log x is equals to 2 times this. So if after multiplying you get 3.3482, this automatically, you know that this is also like you're putting, there's a 10 here. Another way of writing this is the logarithm of x to the base of 10 is 3.3482. So that means 10 raised to power 3.3482 equals to x. To break it further, you can make this as 10 raised to power 3 plus 10 raised to power 0.3482, laws of indices, right? They give you addition of 3 plus this. Remember, just like this is the rule now. Remember, if you have 10 raised to power a times 10 raised to power b, it gives you 10 raised to the power a plus b. That's the principle we applied. So that's why we have it here. So now to get this means that we're going to do the anti-log of this. That's the log inverse of this. Why is it log inverse? You already know that 10 raised to the power 3 is 1000. But 10 raised to the power 0.3482, you want to use your tables. Why is it log inverse? Okay, let me explain. You can rewrite this. If you want, you can write this as logarithm of f to the base of 10 equals 0.3482. You know, this and this are the same. Why? Because 10 raised to the power 0.3482 is, it will give you a number, and we don't know that number, and we assume the number is f. And then, since we assume that the answer to that is f, so the other way you can rewrite it is like this, in logarithm form. Logarithm of f to the base of 10 equals to 0.3482. That tells us that for us to look for f, that means we have to take log to the other side. So f will now be the log inverse of 0.3482. So looking for the log inverse is like, that means that you're looking for the antilog. So using our tables, we're going to get 2.23. So that means that the answer to this is 2.23. So then we'll multiply by 10 raised to the power of 3. We know the answer to 10 raised to the power of 3 is 1000. Now do 1000 times 2.23. Having done that, goes 1, 2, 3. It gives us 2230. That's the value of our x. 2230.
Shedema tutors. Game over.